So the next one we do is what? Is this cutting the, we go back to visit to what? Cutting the rectangle again. The reason this time I put this problem over here is, actually I want to talk about Yannick's old method about 9 by 16. Yannick the other day did this. This is 9 by 16. And what did you do? You basically did a perpendicular. Somewhere over here you produced what? A 16, right? 12. Oh, sorry, 12. Because your final thing you want to end up with 12.
Yeah.
So then you make a perpendicular here, and then you do this way. So this thing goes to what? 1 goes to 1, and then 2 goes to 2. The slide, right? So this measure is very, very nice, but we were a little bit rushed the last time. When you point out some certain things, we didn't go over very carefully. Does this measure have a limitation?
I think this method works until the aspect ratio is 1 to 2, and then after that, the perpendicular cannot reach each other.
So it's possible you have things like this. When you produce this line, you force your intersection to be what? Outside, right? So that's the limitation.
Yeah.
This is why I want to talk about this kind of method is, now we understand the domain very, very naturally. Why there are certain things constrain your what? Your constructions, right? It's not very artificial, because this very naturally, you can see if I give you something else, this goes out. And where's your 1 to 2 ratio come from? It's basically you wanted the most what? Borderline case, right?
Yeah.
That's the case you can barely have, right? And then you can see this angle goes to what? This angle. But these two triangles has to be what? Congruent, right?
Similar.
These two triangles are similar.
Yeah.
But the trouble is, this side is facing the what? This angle. So actually, if they are similar, actually now I force this to be what? 40, 45, and 90. Because this B is facing this angle, right? But this B is facing what? This angle. So that's the trouble. So if this is the borderline case, basically we are saying this B facing the two different angles, right? But because they are similar, these two triangles must be what? Congruent. So I know this is actually equal to what? Equal to B. So that's why Yannick was talking about is the borderline case is 2 to 1 ratio. And if it's more than 2 to 1 like this, it doesn't work anymore, it pushes it out. Right? So that's why I said, let's do another what? Construction. So the construction we have to compare is this time, is this one. It's 1 by 3. So clearly, this measure doesn't work anymore. Because if you draw this, the perpendicular will be outside. Okay? But you look at this method, the main idea is still very valid. It's basically something about what? Swing this square, the desired square, this way. And you just want to show which way you can make the swing and it allow you to what? To make the translation. So if we extend, we know this part is always congruent to this. So this part can go to here. And this is the overlapping part, right? So that's good. So the only thing I need to show is how I put this part equivalent to this part. So this tells me,
but you have 290 degrees there.
yes, they're not completely the same. That's very good. You already spot. What's the key thing?
You have 290 degrees there, but
They're
they're
next to each other. And over here, they are not next to each other, right? But at least I know this. These two should have the same what? Area. So really try to make this and this are more closer to each other. Where should I stop at this point? I have a chance to make them more close to each other with less cuts.
Well, if you wanted to just swing the piece around, it would be good to pick a midpoint.
Pick the midpoint, because at least I want these two parts to be what? To be the same, right? So I know now these two are close. The angles are the same, but it's just in a different order, right? So somewhere over here, I have to make a what? Kind of like a flip. If I make this 90 degree to here, then I'm okay. And I know this is a what? So this is the good thing about Vinja was saying, pick the midpoint. Pick the midpoint. I'm looking at this side. This is basically a fixed what? Trapezoid shape, because the angle is already fixed. So I have also the same base. So basically, it's where I stopped, right? And I know these two have the same area. So if I go up enough, these two should be the what? Be the same. So if I go up enough, these two should be the what? Same area. So that means these two triangles left over here should be the what? Should be the same. So that means if I make one more cut here, I flip this over here, and then I should have it. Right? So this is a much more difficult way than this, but it does cover the things that this guy cannot cover. Because when the dimension gets worse, this one can help you a little bit more.
So what are the limitations of this one?
That's a very good question. The limitation you already see. I need to draw this kind of like over here, have enough length. Right? So all these problems will fail if this becomes what? Very bad, like this.
But this length, and this length are the same, right?
Mm-hmm.
So it's twice of your side length.
Right, but you see, if all of them becomes very bad, instead of 1 to 3, let's say make it 1 to 8, then even you go through the midpoint, you will see it's trouble. Well, first of all, I'm not even sure if you can make the midpoint here, right? And then the second thing is what? This one becomes what? Actually what? Too short. It doesn't go through the midpoint anymore. That's the real issue. Because if you take, so for example, 1 and 9, this is only length 3, right? It doesn't go through. So then you have still more limitations now.
Yeah, and the farthest we can get is 3 root 2.
It's 3, and then we clearly cannot get it here.
Yeah, and 3 root 2 is less than 4.5.
And intuitively, if you have a long rectangle
Yes.
and you want to combine it into a square, you need to make lots of
Right.
cuts. You cannot make two.
Exactly. So the key thing is actually to do what? To cut the rectangles to make it more like this.
Yeah.
And then we can what? Then we can cut.
So in that picture, not how many cuts do you have, how many parts do you have?
I need 4. This measure needs 4. This measure needs 3. Right?
So 4 is it the minimum for that?
No, they can do less. Because in the first one, we already talked about another cut that Vinja talked about. I think that's the most efficient one. I think that this is the most general and efficient one. Is you make a square like this, and you make this cut. This covers this method, this covers also this method. But for this kind of thing, this method still does not cover, but those are too wide. You have to, for example, cut it half and stack them together and apply this guy. Right? And also in a sense, this method is good, is it combines all their strengths. This method only involving translation. That method also only involving translation, but this method involves what? Rotation pieces, right? But just